Taylor here, Dr. Taylor. Welcome to Dr. Taylor's Pedagogical Notes. Today we're going to look at rational numbers, or fraction multiplication. Okay? So to multiply fractions, we're going to look from concrete to abstract. And we'll start with concrete. We're going to stick with the geoboard. But now you only need one. Okay? Before with addition and subtraction, you needed two geoboards. But here with multiplication, you just need one geoboard and you can work independently. We can still group together in two and think collectively, but one board is enough to do the problems. So let's begin. So still we look at the denominators of the fraction, right? And we know we're going to use rubber bands, and all this is, has been repetitive in this presentation. So there you are. We're going to still use the green rubber band to represent the perimeter of our area model, and it is going to be the dimensions of the denominators, 3 by 5. Okay? So I'm going to take a green and I'm going to capture a 3 by 5 area. All right? And now I'm going to do just like before. I'm going to divide one set up vertically and one set up horizontally. The first one is the thirds, and so I'm going to divide it into the thirds. Okay? And so I will use the red rubber bands, and boom, I have 3/3. Okay? I know I only want 2 of them, but for now, I've got to have something cut into thirds before I can take 2 of those 3/3 away from it, right? Okay. Next, I'm going to go ahead and do the horizontal divisions with the blue, right? It's in fifths, so I'm going to have 1, 2, 3, 4 rubber bands cutting this piece into 5 different sections, right? So my fifths are getting measured horizontally, and my thirds are getting measured vertically. So now let's take a look. It's a little bit trickier. If I just use beads, it could get confusing. So I'm going to use nickels and pennies, right? Or pennies and dimes, I should say. Either way, whatever will fit in your little geoboards. Okay? If they don't fit, then you might use a penny and a bead, right? Or something like that. Something that will work. All right. So let's go ahead and say we got the numerator of 2. So we should somehow highlight 2 of the 3 vertical partitions, and we're going to go ahead and use nickels. And again, like I said, you can use pennies and dimes. They have to be a different size. That's the thing. And it's nice to use pennies and something silver, because then it's a contrast of color. So I'm putting in here. Could I have started there or there? I could start anywhere, but I just need to fill up 2 of the vertical partitions, right? Because that's the 2 numerator of mine. So there is my nickels, and I stack them up, and bang, that represents 1 of the third, right? I'm going to keep going. I could put it here or there, it doesn't matter. I'm going to put it there, and I keep filling up until I get, boom, that's 2 of the thirds. 2/3 is what I want, so I stop putting nickels on the board. Right? Not too bad, okay? Next, I want to represent the fifths, and I'm going to use pennies for that, because pennies are smaller than nickels, and I can put them on top, and the color and the fact that the size is smaller lets me see where there's 2 things on any one particular square. So I will use pennies, and I'll put them across any one. I'm going to put it right there. So there's the pennies, and now I filled up 1/5. Well, I'm done, because 1/5 is all that I was contending with. 2/3 times 1/5. So I want to show 2/3 1/5 time. So let me ask you a question. If I'm showing something less than 1 time, is that number going to grow or shrink? Can you see how it makes sense when you think about what fractional parts mean? So what I want to look at next is, where do I have both a nickel and a penny in a square? All right? So as I look at that, I can see that there's only 2 places, right? 1, 2. All right? So now, I said it takes 2 bunnies to multiply. I love to use the biology and what have you. No bunny is going to be multiplying by itself. It takes 2 bunnies. So I'm looking for 2 coins. 2 coins like the 2 bunnies. Where the 2 coins are, multiplication is happening. That's kind of my biological tie-in. Okay? So there's the place. There's 2 places where both coins appear in a single square. How many possible squares were there? I think you can see where this is going. What's that final fraction going to be? Right? The numerators, there's 2. What is the denominator value? It is the dimension of the rectangle, which is 3 by 5. Or I can count all the squares up in total, and I can see that 3 times 5 is a product. And those 2 are how many out of 15? that I have. So 2/15, is that more or less than 2/3, right? Think about it. If I cut my pizza into 15 equal pieces and I only gave you 2, and I cut another pizza into only 3 big pieces and I took 2, would you feel like you got a good deal, right? It would feel like, no, you got much less than the 2/3, didn't you? And that's what happens. This is like saying divide 2/3 by 5. Cut it into 5 pieces. I didn't mean to do that. So 2/3 times 1/5, that's like saying one of these things divided by 5. That's kind of what those are saying. There's a lot of knowledge in that I kind of pushed into that for you quickly. But if all else fails, you go back to where do the 2 things appear. The 2 bunnies can multiply, so there's 2 places where that's happening out of all the places they could be hiding and multiplying. Okay? All right, graphical, same thing. I'm going to draw the pictures. So I'm going to go quickly. There's my thirds. There's my fifths, right? I'm going to color in 2/3. There's 1/3, 2/3. I'm going to color in 1/5. There's 1/5 right there. Now where they overlap, I'm going to put a different color just so we can tell what it is. Okay? So that means that there's how many places where blue and red overlap, and what does blue and red make when you mix the colors? We're doing a little bit of art now, right? Always think cross-curricularly. Hook it to context. Blue and red mixed together. If you don't know, right, then have them take 2 markers and make a blue and a red over them quickly and see what they become. Bring in a little bit of, acrylic paint and let them mix a little blue and red. Give them little bitty, put a drop of each on a paper and have them mix it around with, a stick. And let them see the purple emerge. Make it meaningful, right? Don't be afraid to slow down and take more time. You're never going to keep the pace you want to keep. And if you do, they're not going to get the content you want them to understand. The scores are going to be low if you rush through it, okay? So give them a chance to understand. And the more they understand, the more they'll get right. And if they do less but get more right, that score is more meaningful. They're more prepared to be successful. Ramrodding them through an entire set of content, having them drill and kill in the last 3 weeks so they can memorize it, and then they don't remember it the next year, and if it doesn't look exactly like what they practiced, they can't do it. Those things are common. You hate it, you're frustrated, you complain about it. This is how you get around it. There's only one way, taking the time to build the understanding. No other way will work. And the only other way it works, you think it's magical maybe, but it's not, is they go home and they take the time until they figure it out. Right? Many times going home isn't conducive. You need to make that class time, that conducive learning time. Right? And forget about giving them dozens and dozens of homework problems. Give them 4. Right? If you do meaningful classwork and you give them 4 questions that are, 4 strategies where they can make a mistake, and if they make one, you know where they're weak and you can group them and differentiate. It's just that simple. Don't be afraid to change what you're doing. You got to. If you don't, you're going to stay miserable. Kids are going to stay miserable. The job is going to get more and more depressing, and you're going to burn out and quit. And the kids are going to get out, and they're not going to have a future. And then you're going to be left with a piece of society that can't perform. There's just nothing good about not changing. I guess that's what I'm getting to. It's okay to not want to do it because it's work, but you can do it, and it's not that hard. You just have to commit yourself to it, and you'll be surprised at the returns. You really will. Okay, so there's 2 out of 15, right? I don't have to belabor that too much. And finally, of course, the abstracts, I can think about it. I can think about what it is. This should say times. So I've really messed up some of these slideshows. It's good I captured on video, right? So if I'm doing multiplication, then it should be 2 times 1/5 is 2/15. All right? So thank you very much. I will adjust those. But in the meantime, enjoy the slide. You caught me being imperfect. That's a lesson too. If you can't roll with the mistakes, and you can't smile and realize I'm a human being and I'm imperfect, then the kids they're going to expect to have to be perfect to be right. And you can be right and imperfect. You can be imperfect and be wrong and discover what was right. See your own mistakes and make the adjustment. That's a far more critical skill, metacognitively. All right? So please join me for division, which is really an elaborate thing as far as trying to understanding how to partition rational numbers. Might not be what you want to drive the kids through over and over again, but once will help you to let them see how to make that one-to-one relationship, to compare how many it is when I'm partitioning rational numbers. All right, thank you, and I will see you there.